Hello and welcome to the Geodict 2022 Advanced GeoPython workshop. Before we start, please make sure that Geodict is running on your machine. Also note that if at any point you are lagging behind or if you do not want to follow the workshop interactively, you can also find all the results that we are producing during the course of this workshop in a subfolder of your workshop materials folder named M2M Results. My name is Rolf Westerteiger and I did my diploma in computer science in 2008. Finished my PhD in 2014 together with the German Aerospace Center and the University of Kaiserslautern, and I've been a full-time senior software developer at Math the Market since 2014. After attending this workshop, you will be able to access simulation results programmatically using GeoPython. You will learn how to structure your GeoPython code into functions, which is very helpful when doing automation. We will also show you how to perform simple automatic material optimization loops, and you will learn how to create custom PowerPoint reports based on your simulation results. This workshop consists of 3 parts, where each part is roughly half an hour session, followed by a 10-minute break. During the whole workshop, my colleagues will be available in the WebEx chat to answer your questions, and I will also be available in the break time after each block to answer your questions orally. In the first part, we're going to be recording a macro which generates a simple fiber geostructure and runs a flow simulation. We will then extend that macro in order to access the produced GDR file and extract the permeability value from it. We will then learn how to reorganize that macro into functions in order to make it easier to reuse for the following steps. In step 2, we are going to be looking at loops, at automatic material optimization, and at plot generation. In the third part, we will put all of this together and create custom PowerPoint reports from your simulation results. One of the most important concepts in Geodict automation is a so-called command. Almost every action in Geodict is a command, for example, loading and saving files, structures or results, starting a simulation, or rendering an image or a video. Each command consists of a name and a set of parameters, for example, the result file name, the boundary conditions when running a solver, the solid volume fraction when generating structures. Almost all actions in the graphical user interface execute a corresponding command in the backend. When you record a macro, this macro will consist simply of a list of these commands together with their parameters. When playing back this macro, it will run the same commands with the same parameters again. Also note that macros can have variables which can then be defined in the graphical user interface. But please see the beginner's workshop for Geodict macro variables because we are not going to be using them in this workshop. Now, without further ado, let's dive right into it. You should have received your workshop materials and unpacked them somewhere on your machine. In my case, I have them on my desktop here. The folder should be called Workshop GeoPython Advanced. The first thing I would like you to do is to change your project folder to a subfolder of this folder. Namely, go to File, choose Project Folder, select Project Folder. Then go to the Workshop GeoPython Advanced folder and go into Project folder. This is an empty folder prepared for our results. Now, the next thing I would like you to do is go to Model, Fiber Geo, select Create down here, then go to Edit and change the voxel size to 100 by 100 by 100 voxels and click OK and then click Generate. There should probably a result viewer popping up on your screen. You can just close that for now. Next, go to Predict, FlowDict, select Stokes-Brinkmann, the first option down here, and click Run. This runs a flow simulation on this small structure, which should be very fast. Again, you can close the result viewer. And now we're going to be looking at the session macro. You can access this by going to Macro, Session Macro. And as I mentioned earlier, Geodict keeps track of the list of commands that have been executed, and you can see all the commands that have happened here since the start of this Geodict session. Namely the FiberGeo command, FiberGeo create that we did, and the solve Stokes command here. So the first one is the structure generation, the second one is the flow simulation. Now we want to create a macro from these two steps. So we select FiberGeo create first, then we hold Control and select solve Stokes as well. All the other commands here are not important. For example, this load GDR file is the opening of the result viewer, and the close all GDR file is the closing of the result viewer. So we only take these two commands, select them by holding Control and clicking, and then we click Add Selected Commands to File. Basically, what we have down here is like a staging area where we can move individual commands in order to then write them out to a Python file. To do this, we go to Save, and we name our file workshop1.py. And as you can see, we're in the project folder, and it gets saved there. So click Save, and we can close the session macro. Now let's go and look at the macro that we've just recorded. For this purpose, go to the macro menu, go to Execute Macro Script, unfold the project folder if it's not unfolded yet, select workshop1.py and click Edit down here. This will open the macro in a text editor. As you can see, there are several Prolog blocks in the macro here which are Geodict specific, and I will go through them one by one. First of all, we have the header. The header gives you the Geodict version with which this macro was recorded, the time and date when the macro was recorded, the username of the author, and the platform on which the macro was recorded. Then there is a description text, which is a multi-line string that you can edit freely, and this string will be shown in the execute macro dialog. So the purpose of this string is basically to describe what your macro does to other people that might want to use it. Then there's a variables block. As I mentioned earlier, we're not going to be using variables here, but in this block you can give your macro additional variables, and the user which executes the macro can then set values for these variables directly from the user interface. And down here is a large comment block which explains how you can use variables. This is basically the header of the macro. These are Geodict specific blocks, and this is followed by normal Python code. Namely, there is an argument block for each command, which goes until here, and then there is the actual command call here. So this argument block is a Python dictionary which consists of key value pairs, as you can see, in a structured manner. So there's a hierarchical structure to it. And you can actually fold these blocks together if you're using Notepad++, which we suggest. So for example, I can fold these blocks by clicking on the minus signs here. I can basically collapse one part of the whole tree. And likewise, I can also collapse this whole block of parameters. So now it's much easier to see what's going on. We have a definition of the arguments for FiberGeo, followed by the actual command invocation. And this, of course, is followed by the flow simulation. I can also these are the flow solver arguments. For example, you can see the name of the result file, which we're going to make use of later. You see the solver selection, the Lear solver is selected, etc. But for now, I will also just fold this away by clicking the minus sign here. And now we can see the actual structure of the macro. So we have a FiberGeo create command, followed by a flowdict solve Stokes command. Next, let's take a look at the flowdict simulation result. We go back to Geodict. And here we go to File, Open Results, GDR. Then we select the Stokes result file, the GDR file here in our project folder. And this will open up this result viewer, which shows us some data about the flow simulation. And you can see here that we have a permeability tensor, and because we computed the flow in z direction, we might be interested in the permeability in z direction, which is this value, which you can see here in the user-readable report. But if we want to access that value programmatically, we have to find it in the result maps. The result map can be found under the Result tab in Map. So if we go here, we can find all kinds of structured, hierarchical, computer-readable data, which gives us the flow simulation results. And if we look through this, we can see that there is a permeability 3.3, which is the permeability in z direction, here in the result map. And what's important here now is the name of the key, namely permeability 3.3. We note that key, and then we can continue and access that value programmatically. Now, in order to do this, go back to Notepad++, to the file workshop1.py. Then first thing, please save the file under a different name. Go to File, Save As, and save it as workshop2.py. Now go down in the code to the solve Stokes command, or rather to the gd-run command floating solve Stokes. And here we go and write gdr_name equals that line. What this does is this run command returns us the name of the GDR that was just generated, and we can use that to open it afterwards. Then we do import string map. This loads a library that we need to open GDR files. And then GDR equals string map dot parse GDR name. What this does is it opens this file and parses the content and saves the content under a variable called GDR. Now what we wanted to do is to extract the permeability value, which is stored under the key permeability 3.3 in the result map. To do this, we do the following: perm equals float of GDR and then quote. Note that you can use single quotes or double quotes interchangeably, but not mixed in the same string, but we could have also used single quotes here. And then we go result map, permeability 3.3. So what this does is it gets the value for the key permeability 3.3 in the result map. There are also different maps. There are, for example, also the input map, which gives the input to the command, but result map is the results. So we go to result map, permeability 3.3, get that value. And these values are always strings at first, so we convert them to a float value here, because it's actually a floating point number. And then we go gd message box, msg box, perm. So after the value is stored in perm, we then display it. This is a special geodik function which opens a dialog box which can show any text basically. At this point, please make sure to save the file by pressing Ctrl S. Now we go back to geodik and go back to the macro execution control. If it's not open anymore, just go again to the geodik user interface, go to macro, execute macro script. And there you should find workshop2.py. If it's not there, you might have to click refresh down here. Now we select workshop2.py and click run again. And if it asks us to overwrite, just please click overwrite in the center. The question comes up because the macro generates the fiber structure again and runs the flow simulation again. So it asks us what to do with this with the GDR files of the same name. So now we see that that the permeability number has been output in a message box here at the end of the macro. So what it did is generated a structure, ran the flow simulation, and then it opened the resulting GDR file, extracted the permeability value, and showed it to us. Now let's again go back to Notepad++, to the workshop2.py file. And again, we save it as workshop3.py. And now what I want to show you is how you can reorder this code into functions in order to make it reusable. So we start by going above the line create args1 and introduce a function definition by writing def create structure and run simulation, then bracket svp closing bracket colon. This introduces a function. That's what def does. The function is named create structure and run simulation because that's what the function is going to do. And this function gets a single argument called svp. This is for solid volume percentage, as you will see. Now, one more thing we need to do is, so Python knows where this function ends. We need to indent the code which is supposed to be part of the function. So we take all this text, and as you recall, this corresponds to a lot of text here if we unfold it, but we can keep it folded. So we just take all this text, mark it, that is the create args and the solve Stokes command, and press tab once. And that tab will indent the code. And now it will also unfold it automatically, but we can fold it again. And what this indentation signifies to Python is that this block, this text block, is supposed to be part of the function. So this line import string map is not part of the function anymore. So when this function is called from somewhere, just this part executes. Now, as you probably know, the FiberGeo structure generator usually works with a goal of reaching a certain solid volume percentage. So that's basically the opposite of the porosity. So you give, for example, a solid volume percentage of 10%, then it will try to fill the volume with 10% of fiber material. And now what we want to do is we want to extend this function so it will take this SVP value and generate a structure with a given SVP. As we have recorded the FiberGeo call earlier, currently these arguments contain a fixed solid volume percentage, as we will see. So unfold this create args1, and we will scroll down and see solid volume percentage here. So again, this is a key value pair. So we have the key solid volume percentage here, then a colon, and the value here. This value can optionally contain a unit. In this case, it's percent. So when we read this, we know this is percentage value. So as you can see, there's a fixed value of 10 recorded here. So each time this FiberGeo runs, it produces a solid volume percentage of 10. And now if we write instead SVP, then it will insert the value of this SVP argument that we introduced in our function in the place of the 10% that we had earlier. So whenever this function is now called with any SVP value, it will first generate a structure with a given SVP and then run a flow simulation. And one more thing that we would like to do in order to keep our results separated is we want to make the result file name also a function of this SVP value. So we go and find the result file name line here, which is called FiberGeo GDR, which is the default for FiberGeo. And we add an F, small f, in front of this first quote. And we write, instead of FiberGeo.gdr, we write FiberGeo underscore, and then curly brackets opening, SVP curly brackets closed. What this will do is it will actually introduce this SVP value as part of the file name, as you can see here. So it will take the SVP and insert it in this part of the file name. And likewise, we do the same with solver argument. So we go down to the solve Stokes args, unfold that, and there's also a result file name, and we go add an F in front and do Stokes result underscore curly brackets SVP. So now each time this function is run, it generates a FiberGeo, say 50.gdr, and a Stokes result 50.gdr, for example, for an SVP of 50. But right now, as the code stands, nothing will happen because the function is never called. Oh, I just realized I made a mistake here, but just easily fixed though. Please also include this code down here in the function by just selecting it and pressing tab once. Now all of this is part of the function. So it will also at the end of the function extract the permeability value. But instead of displaying it, we now do return perm instead of GD message box perm. Now we have a function which creates a structure, runs a flow simulation, and gives the permeability, all for a given solid volume percentage of the structure. Now that we know that what this function does, we go up here, all the way up to the function, and just fold it away by clicking the minus in front of the def. And now, next, what we do is we actually call our function. We do perm equals create structure and run simulation. And we give it, say, an SVP of 25. And then again, we open a box showing us the resulting permeability. Now this calls our function, gets the resulting permeability and shows it. Now let's save the file again by pressing Ctrl S and let's go back to Geotic to try it out. Go back to the macro execution dialog. Again, click refresh here. So we see workshop3.py. Select it and run it. And we now get the permeability for the new structure with an SVP of 25. And we can see that we have, if we close the macro execution dialog, we go to File, Open Results. We can see that we now have a FiberGeo25 and a Stokes Result 25 GDR file here, which corresponds to the structure generation and the flow solver results. This concludes the first part of the GeoPython Advanced workshop. You have learned how you can record a macro, how you can access simulation results, and how you can reorganize the code of the macro into a function in order to make it reusable and make the structure generation parametric. In the next part, we're going to build on that and call this function automatically with different values in order to do a parameter study. Now, if you didn't quite catch up, please feel free to go to the M2M results folder and copy the intermediate files that we have generated here over to your project folder, namely workshop 1, workshop 2, and workshop 3.py. Then we can build on that in the next part. Now there's going to be a 15 minutes break, so feel free to ask any questions either orally or in the chat. Otherwise, see you in 15 minutes.